the leading term is 2y squared, and this is the leading coefficient. Leading coefficient. This is what we like to call the free term. Why free term? It's because it doesn't have y. So this is in descending order. I cannot use a special product. What do you mean by special product? I mean these two. How come I cannot use any of these? Because this is -1, right? And this is not a perfect square. So this has to be a perfect square, right? We had a squared here. So a special product is not applicable. And 1 is not the leading coefficient. So this is the most difficult type of polynomial, quadratic polynomial to factor. So what am I looking for? I'm looking for a product. I'm looking for two numbers whose product is this. 2 times -1. So this is always the product. These two. Product. And this is always the sum. What is here? -1. So this is the sum, always. And this is the product, always. So can anyone give us two numbers whose product is -2 and whose sum is -1?
-2 times 1.
Now let's check. Is the product -2? Is the sum -1?
Yes.
Perfect. At this point, we know that these are the numbers we need to use. I am going to replace this by -2y plus y. So 2y squared, -2y plus y, and -1. Sorry. How many terms we see now?
4.
4 terms. What is the most applicable method for 4 terms? How do we call it?
The factor by grouping.
Thank you very much. Who said that?
Elena.
Thank you very much. Factoring by grouping indeed. So I'm missing my props. From the first 2 terms, what would you factor out?
2y.
What is left in parentheses?
Y minus 1.
Excellent. What do I have to have in parentheses? I refuse to look. What do I have to have in parentheses so that this works? Of course, I cannot fabricate it.
Y minus 1.
It has to be, thank you very much. Who was that?
Elena.
Thank you. Good. Now I will uncover this and find a sign and a factor. The sign must be there, the factor must be there. Can anyone give us the sign and the factor?
Sign is positive, the factor is 1.
I need one sign. Maybe I didn't hear what you said. My apologies.
Positive,
Oh, you did say positive, and the factor is on. Excellent. We don't write the 1. If it were anything else, I would. But the 1, we know it's there. Good. What is the common factor of these two? I need to pull it out. Y minus 1. What is left in parentheses from the first product and from the second product?
2y plus 1.
So then I have 2 options then for y. From y minus 1 equals 0, I get
1.
and from 2y plus 1, say it again.
-2.
Or,
We move 1 to the other side, it becomes negative. And we divide by 2.
negative 1/2.
Negative 1/2. So is this done? Far from. Because we only solved for cosine. That's cosine is y. So then I know that cosine must be 1 or cosine must be negative 1/2. So I'm barely halfway through. Questions before I continue? Let's stop and see if you have questions, please. Anything? How do you feel about this method? Does it make sense? It does not make sense? You prefer the guessing method? I'm fine. Use any method you like. You are never going to hurt my feelings if you say, nope, I don't like your method. I prefer my own. I'm fine with that.
Does this method, is this something that can be searched? Like, is this called something?
It's not called anything. I like to call it the long method because I think the guessing method with certain numbers is even longer. But I don't know for sure if it has a name. I call it the long method. Okay, so finally, and again, you cannot use, for stuff like that, you cannot use TI-89, 91 to do the work for you. So please remember. Okay, so cosine equals 1. Let's start with that. Let's go to the unit circle. Here's the unit circle. I know it doesn't really look like a circle, but please bear with me. It's close, but not really. And let's look at an angle, a central angle. I would like to spend the time on this now because I hope that moving forward we don't have to do it again. That's slow and with all the details. Okay, so this is the angle X, and this is the unit circle, which means the radius is 1. In a right triangle, if I want to determine sine x, assuming that this is the height, I'm going to call it A, and assuming that this is the adjacent leg, I'm going to call it B. Can anyone refresh our memory? What does sine x equal to?
Isn't it opposite over adjacent, so it'd be A over B?
Careful, that's tangent. So sine is the opposite over the hypotenuse. So A over 1 will be just A. So this height in a unit circle, this height is nothing else but sine x. Good. Can anyone give us cosine x?
B over 1.
Yes, it is B over 1 is the adjacent over the hypotenuse, so this is B. What do we conclude here? We conclude that cosine is measured on what axis? Cosine x, or just cosine, is measured on axis.
Would it be the x-axis?
Good. And where do we measure sine?
The y-axis.
Very good. So, which means, how much is this? For 90 degrees, or pi over 2. How much is this height?
One.
Good. So what will you say? What is 1? Sine of 90 degrees or cosine 90 degrees?
It would be sine because it's on the y-axis.
Exactly. So here, sine 90 degrees equals 1, or sine pi over 2. Very good. What happens here? And of course, how much is cosine here for 90 degrees? How much is cosine?
0.
Yes. Of cosine 90 degrees is 0. Can anyone tell us what happens at this point?
-1.
For what? Okay, -1. What does it mean?
Cosine.
Very good. Cosine x is -1. How much is sine x for this point?
0.
Excellent. So see, you already know all these corners now, so to speak. Here, right, I have 0 for sine, 1 for cosine. Here I have -1 for sine and 0 for cosine. Because cosine is measured on the x-axis and sine is measured on the y-axis. Okay, so I'm back to cosine equals 1. Let's solve that. That's why we had all this discussion. Where is cosine 1? On the unit circle.
On the northern part of the y-axis.
It'd be farthest to the right on the x-axis.
Right, it's right here. This is where cosine is 1. So you can express it as x being 0 plus 2 pi k, or 2 pi plus 2 pi k, but this is okay. So what is this? K is any integer. 0 plus or minus 1 plus or minus 2 and so on and so forth. What does this mean? If k is 0, then is this point. If k is 1, then is 0 plus 2 pi. If k is 2, then it's 0 plus 2 complete rotations. And I can go on forever. What if k is -1? It's this, and I land at the same point. What if k is -3? And I land at the same point. The same starting point, the same ending point. And its cosine will still be 1. Okay, finally, we have cosine equals -1/2. Back to the unit circle. Again, where do we measure cosine?
On the x-axis.
Good. So where will cosine be -1/2? Which quadrants?
The second one. Yeah, right.
Second and third. Where is -1/2? If this is -1 from 0 here, so -1/2 will be here. I'm going to draw a vertical line at -1/2. This is the starting point, and this is the ending point. So this is one angle. I'm going to call it x1. But there is another one with the end point here and the start point here, which is this. I'm going to call this red angle x2.
In quadrant 3, right?
Say it again. Yes.
It would be in quadrant 3 because it's negative.
Yes. It's -1/2. If I say +1/2, then I'm going to be here on this side. But if it's cosine, oops, sorry. If cosine x is negative 1/2, this is negative 1. This must be negative 1/2. This is negative 2. This is negative 3. So this is negative 1/2. So for this to be the cosine, I have to have this angle. For this to be the cosine, I have to have this angle. That's why I drew the vertical line through negative 1/2. Was that the question? Did I answer your question, or I was off on a tangent? Was that okay? Okay, good. So now we have to think in terms of a little table that I will kindly now ask you to remember moving forward. So this is pi over 6, this is pi over 4, and this is pi over 3. Pi over 6, or 30 degrees, pi over 4, or 45 degrees, pi over 3, or 60 degrees. And this is sine x, and this is cosine x. Anyone remembers what is sine of pi over 6? The easiest angle, 1/2, and in the table, the opposite, 1/2. Cosine of pi over 6 is the square root of 3 over 2. Opposite in the table, the square root of 3 over 2. This is the easiest angle of all because it's the square root of 2 over 2 for both. This has to be memorized. It's only 3 numbers. 1/2, 1/2, the square root of 3 over 2, the square root of 3 over 2, and the square root of 2 over 2, both the same.
Where it says 45 degrees, is that pi over 4?
Yes. I drew it too small of a table, I'm sorry. Yeah, you divide 180 by 4, you get 45. Pi is 180, yes. Okay, perfect. Now, I need to identify the reference angle. This piece is the acute angle formed between the x-axis and the terminal side, which is the same thing with this angle. The x-axis and the terminal side, right here. Same thing. Can anyone tell us what is the reference angle equal to? Look at this table and say, I know the reference angle must be blah, and I'll put it in. If it were 45, I would have had here the square root of 2 over 2. I don't have the square root of 2 over 2.
It would
Right?
be 60.
It will have to be 60. Very good. 60 degrees or pi over 3. It's a must. It's cosine. Forget about the sine for a moment. We already discussed the sine. That's why we are in the second and third. The sine was already taken care of. So for 1/2, it has to be this. There is no other cosine of 1/2. I mean, cosine of an angle that is 1/2, but 60. So then I know that this is pi over 3. Good. What angle is this? From here, here.
180 degrees.
Very good. Or pi. Excellent. So now can anyone tell us how to calculate x1?
Pi minus pi over 3.
Excellent. We'll calculate in a moment. Can anyone give us x2?
Pi plus pi over 3.
Yay! Awesome. So 3 minus 1 is 2 pi over 3. 3 plus 1 is 4 pi over 3. Awesome. Okay, so now we have to write those solutions. So then x equals 2 pi over 3 plus 2 pi k. This is the period for cosine. And x equals 4 pi over 3 plus 2 pi k. I always have to express what k is, but I already did on the previous page, but I'm going to do it again here. K equals 0, plus or minus 1, plus or minus 2, dot, dot, dot. Yes, it took us like forever